homogeneous linear systems, the general n by n homogeneous system of linear equations is of the form. So recall that in general systems we have b1, b2, bn here, but for homogeneous systems we all have they all equal to 0 here. So we have n unknowns, x1, xn, and given n equations, so 1 to n, with constant coefficients a, I, j, and in matrix form we write ax is equal to 0. So what is A? A is the coefficient matrix, A11, A12, A1n, A21, A22, A2n, and we have AN1, AN2, ANN. So this is the coefficient matrix A, and we have x1, x2, xn, which is equal to 0, 0, 0. So this is A times, we write x is equal to 0 in this case. So we work with square matrices. So this is an n by n matrix. This is an n by 1 matrix. When we multiply, we will get n by 1 matrix, right? Great. So definition. Okay, let me give a definition. What is a trivial solution? If x1, x2, xn are all 0, right? So if this is x is equal to 0, then a times x is always 0, right? So this is a trivial solution. Or x is equal to 0 is a solution, right? A times 0 is equal to 0, and we call this solution a trivial solution. So it is called a trivial solution. We will study square matrices in this case. So this is important. We have n by n matrix. We study n by n homogeneous linear systems. Great. Okay, we have a remark here. N by n, okay, let me call this 1. So n by n homogeneous system either has a unique solution So we know that trivial solution is already a solution, right? So then the unique solution must be the trivial solution, which is only the trivial solution. So which is only the trivial solution, because trivial solution is always a solution, and if it is unique, it must be it. It has, or the homogeneous system has infinitely many solutions. So we have two cases: has an infinite number of solutions. And we have so we know, and there is a way to understand when we have a unique solution or when we have infinitely many solutions. So which is very nice. So n times n homogeneous linear system, so which is ax is equal to 0, has a trivial solution x is equal to 0 if and only if determinant of a is not equal to 0 and ax is equal to 0 has an infinite number of solutions As you can guess, if and only if determinant is 0, right? Determinant of A is equal to 0. Okay, let me give an example so you will understand better. Okay. Okay, solve the homogeneous system AX is equal to 0. Okay, with a given with an augmented matrix. So A sharp. So A sharp is given as the augmented matrix is given as 0 to 3 0 0 1 minus 1 0 0 3 7 0. Okay, let's find the but we can see that this matrix has determinant 0, right? Because we have, if we have a column or row which is 0, the determinant is always 0. But anyway, we know that in this case, if the determinant of A is 0, we should find an infinite number of solutions, right? Okay, let's find it. So how we find the solution? So we write the augmented matrix and find this echelon form, right? Okay, we have all 0 0 here, and what we are going to do is we will arrange this to be 1. So this should be 1. So how we can do it? I see 1 here. We can exchange R2 and write it to R1. So we will get 0 1 minus 1 0 0 2 3 0 0 3 7 0. Great. And now we will arrange this to be 0. So how we do that? So minus 2 R1 plus R2 and minus 3 R1 plus R3. We will write it R3. Okay, 0 1 minus 1 0. So 0 0 we multiply with minus 2 minus 1, it is plus 2, so we will have 5 here. We always have 0 there. Minus 3 times minus 1, so it is plus 3, so 7 plus 3 plus 7, we will have 10. Great. What we are going to do is, next thing we are going to do is we will arrange this to be 1. So 1 over 5 R2, we will write it R2. Okay, oops, sorry. So we have 0 1 minus 1 0 0 0 1 0 0 0 10 0, and then we arrange this to be 1. Just we will no, we cannot make it 1. So we have already, so we said that in row reduced echelon form, so it is always to the right of the leading is right of to the other leading. So we have a leading here, so this must be 0, right? So this is 0, but it is very easy. Minus 10 times R2 plus R3. We will write it R3 and make it 0. So 0 1 minus 1 0 0 0 1 0 0 0 0, which is equal to 0. Great. So we can read from here. We have so here we see x3 is equal to 0 and x2 plus minus x1 is equal to, x2 minus x3 is equal to 0. So we have x2 is also 0, but x1 can be anything, right? x1, so we don't have, we have three variables, x1, x2, x3, and two equations, and so we have infinitely many solutions, right? We have infinitely many solutions. So for since there is no information for x1, it is a free variable, so it is a free variable, so it can be anything. Variable, sorry. So we will set x1 to be t, and it can be anything. T is in R. Also from the equations we find x2 to be 0 and x3 to be 0. Also from the two equations above, we find x2 is equal to x3 to be 0. What is the solution set? Then the solution set is it is given like this. So x1, x2, x3, which is equal to okay, I will write it here. So what is it? T 0, 0, such that t is in R. So this is our solution set, and we have infinitely many solutions. Also note that determinant of A is equal to 0, right? So infinitely solutions. So this already implies that it has infinitely many solutions, and we find infinitely many solutions. Okay, let me give another example. Okay, solve ax is equal to 0, where a is given as 1, 1, 3, 0, 1, minus 1, 0, 3, 7. Okay, in this case, note that determinant of a is 10, so which is not equal to 0. Then we know that in this case it has a unique solution. And which is, we know it is a trivial solution. X is equal to 0, trivial solution. Okay, let's find it. What is the augmented matrix in this case? So we have 1, 1, 3, 0, 0, 1, minus 1, 0, 0, 3, 7, 0. Okay, we are lucky. These are already 1 and 0, 0 here. We have 1 here, and we need to make it arrange it to be 0. So how we are going to do that? We are just going to multiply minus 3 r2 plus r3. We will write it to r3. So what we get? 0, 0, 1, minus 1, 0, 0. We add minus 3. Minus 3 minus 1, it is 3. 3 plus 7, we will have 10 here. We will have 0 here. And then Great. What we are going to do is we are going to arrange this to be 1. So 1 over 10 R3. We will write it R3. Okay, what we get? 1, 1, 3, 0, 0, 1, minus 1, 0, 0, 0, 1 is equal to 0. So what? Okay, let's read this from this last line. It says that x3 is equal to 0, right? So we have x3 is equal to 0. The second line says that x2 minus x3 is equal to 0. So what does this mean? x2 is equal to x3, which is 0. And the first line says x1 plus x2 plus 3x3 is equal to 0. But we know these are already 0. So here we find x1 is equal to 0, 2. Then what is the solution? So we find x1, x2, x3 to be 0. So x1, x2, x3 is 0, 0, 0 is the trivial solution for the system. By the way, the determinants maybe it is non-zero, but I don't know if it is equal to 10. Okay, exercise. Compute determinant of A. Because I think I write the matrix wrong, so I write to here in this case. So what is the determinant of A? But I'm sure you will find something non-zero. Okay. So next we will learn Cramer's rule for the systems.